When you're working with embedded devices, ultimately you're programming like you would any other machine. However, because these devices are stripped down to the bare essentials, they have a lot more limitations and restraints than you're probably used to working with. One of the things you'll probably notice first is how limited their memory is. For example, the Raspberry Pi 3 only has 1 gig of RAM, whereas traditional desktops have generally 8 to 16 gigs. This doesn't just mean that you can't save things for later, but it also means you can only give it such big a problem to solve because it can only accept so many instructions. The other thing to keep in mind is the speed. The Raspberry Pi 3 can do about 1.2 billion operations per second. It has a 1.2 gigahertz processor. Now that might sound like a lot of things, but when you compare it to, say, a mobile phone, which can do around 2 billion, and traditional desktops, which can do around 3 billion, essentially, you're operating at a third the speed of a regular computer. So things that might seem instantly fast on a desktop suddenly start to take a noticeable amount of time on an embedded device. And then finally, remember, even though we are always using this device as hooked into an AC or wall socket, these devices are meant to be out in the field, out in the real world, probably where wall sockets don't exist. So a lot of times they're connected to a battery. And when you have a battery, you have a resource that's ultimately going to eventually run out. So you need to be really careful that you're not asking too much of the processor, that you're not connecting any unnecessary peripherals, and that you're making sure that you're just not draining the battery faster than it needs to. Ultimately, programming an embedded device is the same skill set as programming anything else. However, you're just going to focus on different goals. When you're making a large software project, you're usually focused very specifically on architecture. Is my code good? Is it maintainable? Whereas an embedded device, well, maybe it's not as important for it to be as beautiful a code or as well organized, but it's so much more important that it's efficient, that it's using the least amount of machine resources, and that it is maximizing the task that you're trying to do as opposed to maximizing the machine's capacity. Ultimately, the more that you program these devices, you'll get more accustomed to working within these restraints. But it's such an important thing to learn how to live within, and once you learn a little bit more about how machines work, it's a great skill to take with you into even, say, Java or Python programming, because we can always work to make our programs more efficient.